state that x is equal to 0 is a regular singular point, so we apply Frobenius method. After that, since it is a means x equal to 0 is a regular singular point, a power series solution exists in the form x to the power r summation m 0 to infinity a m x to the power m, right, where a naught not equals to 0. And after simplification it will be m 0 to infinity a m x to the power m plus r. Now derivative, both derivatives I have calculated, then substituted in the equation, and after that we are getting this type of uh, expressions. And on simplification I am getting this. Okay, तो यहाँ पे जैसे समेशन को जोड़ते हैं सेम ट्रिक आई डिस्कस ईच एंड एवरीथिंग, राइट, मतलब जो भी लिखा हुआ है, तो कोई डाउट है क्या यहाँ पे? नॉर्मली पावर सीरीज मेथड जैसे सॉल्व करते हैं सेम टेक्निक में ये भी सॉल्व करना है, बस इनिशियली जो द पावर सीरीज that is different, x to the power r into summation a m x to the power m form, right? And then you substitute and simplify all the series and add them. So what I told, how to get initial equation, it is the means after equating the lowest degree term, right? After equating the coefficient of lowest degree term. So here x to the power r minus 1, that is the lowest degree of x, and coefficient is this minus of second bracket this. So coefficient of x to the power r minus 1 is equal to 0, that will give initial equation. So it is r square equal to 0 after simplification, and coefficient of general degree term, it is the recurrence relation, right? It means coefficient equals to 0. So here general degree term is x to the power s plus r, and what is the coefficient? It is written. So if we take coefficient of x to the power s plus r is equal to 0, we are getting this. Now r is a quadratic equation, but here both the values are equal, right? 0 comma 0. So both the values are equal. So for one value, always we can find a solution. So that I did. For r is equal to 0, in the recurrence relation you put r equal to 0, so you will get this recurrence relation, and on the basis of this recurrence relation you can find the first solution. You will get the relation between the coefficients, and then you will get one solution. So up to that I told. So how to get the second solution? How to get second solution, that is the question here. So because the second value, the second root for the initial equation, it is same as the first root, right? So if you put r is equal to 0 again, we will get the same solution. So how to get independent solution? You know that different the solutions for OD should be independent, right? So r is equal to 0 केस में अगर दो बार ही कंसीडर करेंगे तो सेम ही सोल्यूशन मिलेगा, एंड बोथ आर dependent. So how to get independent solution? So do you remember that whenever one solution is known, how to find another solution? Reduction of product technique. But y is equal to that u into y1 ऐसे करके, मतलब लेके u का वैल्यू निकालते थे, वो एक शॉर्ट फॉर्मूला था, याद है कि नहीं?
यस
तो वही मेथड यहाँ पे अप्लाई करना पड़ेगा, ठीक है? whenever roots are equal, to find the second root, second solution, second independent solution, you have to consider that reduction of order formula C. the second solution. You just read it. We get a second independent solution y2 by the method of reduction of order, which you have studied in section 2.2 first semester. You means in that method we have substituted y2 is equal to u into y1 into the equation. Then the equation reduced to a first order, and you solve the first order, you will get the solution. Means you will get the u, and accordingly you will get the y2. So what is the short formula, can you tell me? What is the formula to find u? U is equal to integration 1 by y1 square, bolo, e to the power what? कुछ भी याद नहीं है. px dx and whole dx. That is the formula to find u. So after getting u, you multiply it by y1, you will get the second solution. Okay. So if you forgot, you go to section 2.1. Fine. And otherwise you can write this formula also. ये फॉर्मूला ही काफी है, और कुछ पता मतलब पता होना जरूरी नहीं है. Only this formula, u is equal to integration 1 by y1 square e to the power minus integration px dx whole dx. So actually what is px here? y1 that we know, that is a known solution, which is 1 by 1 minus x, right? known solution जो है वो 1 by 1 minus x. तो what is px? What is the form of second order ODE? Y double dash plus px into y dash plus qx into y is equal to 0 और rx, मतलब जो भी है नॉन होमोजेनियस लेंगे तो rx, otherwise it is 0. That is px, means coefficient of y dash in normalized form. Fine. So what is px here? What is px? Tell me. 3x minus 1 divided by x into x minus 1, right?
Yes.
So for second solution, we apply reduction of order method. y2 is equal to u into y1, where, okay, before that you can ask, in the previous solution y1 it is a naught into 1 by 1 minus x, but in the book they have taken only 1 by 1 minus x. Okay, why? Because actually whenever we are applying reduction of order, y1 and y2, those are only function of x. Those do not contain any arbitrary constant. So you take a naught is equal to 1, or you can take any other value of a naught also. Fine. So they have considered a naught is equal to 1, because we are interested only on functions, not in the coefficients. So what is u? Again I am writing integration 1 by y1 square e to the power minus integration px dx. Now what is y1 square? 1 by y1 square, that we got 1 by 1 minus x, and e to the power minus, what is px? 3x minus 1 divided by x into x minus 1, right? Or something else. 3x minus 1 divided by x into x minus 1. Okay. Dx per dx. Now I think you can do that integration, right? Integration 3x minus 1 divided by x into x minus 1. अगर इंटीग्रेशन भूल गए हो तो इंटीग्रेशन भी रिवाइज कर लो because you need this. So I'm not doing this part of integration. Look, they have applied partial fraction, so you can apply partial fraction for this, or you can you can write in that form. You can write px plus q by ax square plus bx plus c form. Actually, that is also known form, na? In that form you write and then you integrate it. So there are various techniques to solve integration. So partial fraction is the better way to handle it. तो partial fraction याद है ना कैसे करना है?
Yes, sir.
So this 3x minus 1 divided by x into x minus 1, you take it is equals to a by x plus b by x minus 1. Then you find the values of a and b. So value of a and b will be 1 and 2. You check it. Ultimately, what we are getting after integration, it is minus 2 ln x minus 1 and minus ln x. Again, we are not putting any arbitrary constant for that integration because we are finding only the independent solution, which is not the general solution. Okay. So ultimately, as I told, इंटीग्रेशन मतलब जो फॉर्मूला है y1 by y1 square e to the power minus इंटीग्रेशन px dx, तो ये वाला सिंप्लीफाई करके आया 1 by x एंड u जो है उसके बाहर में एक इंटीग्रेशन है, तो इंटीग्रेशन 1 by x, दैट मीन्स अल्टीमेटली इट विल बी ln x. So you check it, it will be ln x. Okay. Therefore, second solution will be 1 by x minus 1 minus x into ln x. Fine. Now you can write the general solution. You have got the two independent solutions y1 and y2. Therefore, the general solution is what? c1 y1 into c2 y2. Na?
Yes, sir.
Is y is equal to c1 1 by 1 minus x plus c2 ln x into 1 by 1 minus x. That is the general solution. Look, but one thing I need to mention, not always we will get the solution in closed form, right? मतलब ये जो y1 है यहाँ पे एक simplest form आ गया था सीरीज का and we know the closed form of the series for it. तो इसीलिए second solution निकालना आसान हो गया. But if we don't know the closed form of the first solution, in that case finding second solution is very difficult. So that is the reason in exam, if the first series cannot be written in closed form easily, then they ask for the first solution only. Okay. मतलब पहला वाला solution अगर ऐसे closed form में नहीं लिख सकते, नहीं आता है, in that case वो एक ही solution पूछता है एग्जाम में. Apply Frobenius method to find the first solution or to find a solution. Okay. So keep in mind this language. Use Frobenius method to find a solution. So a solution means y1, only y1, And if it is clearly written that find by Frobenius method find the general solution of this ODE. The general solution means you have to find y1, y2, and then lastly you have to write y is equal to c1 y1 plus c2 y2. Got it? क्या समझ में आया कि नहीं? मतलब कैसा टाइप का क्वेश्चन आ सकता है, मैं क्या बोला? नहीं, रिस्पॉन्स.
yes sir आगे.
Okay, see now in the class every type of problem I can't show because if I take one problem means it will take a whole class. So I am showing some space, some means different type of problems here. uh, Means for each case there are three types of cases, right? एक है equal roots, और एक है not differing by an integer, और एक है differing by an integer. Already that example I have written in the Jamboard. It is a double root case, means equal root case, right? So see, 2x square y double dash plus x into y dash plus x square minus 3 into y 0, and you can verify it. X is equal to 0 is a regular singular point. Fine. X is equal to 0 is a regular singular point, so we can apply Frobenius method. And by Frobenius method, y is equal to summation m 0 to infinity am x to the power m plus r be a power series solution. Then you find their derivatives and then substitute it into the equation. So after substituting and simplifying, uh, we are getting lowest degree term here. It is coefficient of x to the power r. So don't think that always means always the lowest degree term will be x to the power r. It may be x to the power r minus 1, it may be x to the power r plus 1, or it may be anything else. But for that particular equation, that you have to decide which one is the lowest degree term. So for this problem, x to the power r is the lowest degree term and the coefficient is this. So by equating this coefficient to 0, you will get initial equation. So here we are getting two roots, 3 by 2 and minus 1. Now first of all you determine it is which case. Roots are not differing by positive integer, right? 3 by 2 and minus 1 ये दोनों का डिफरेंस इंटीजर नहीं है ना?
No sir.
So that is the simpler case actually. जब दोनों का डिफरेंस पॉजिटिव इंटीजर नहीं आएगा, वो केस में हम लोग मतलब सेम टेक्निक में दोनों सोल्यूशन निकाल सकते हैं. फाइन. जैसे प्रीवियस r इज इक्वल टू 0 केस में y2 निकालने के लिए आई हैव यूज्ड अ डिफरेंट टेक्निक. But when the roots are not differing by integer, in that case finding both the solutions means it is easier. Both will in both case we follow the same technique. So देखो r is equal to 3 by 2. Now that is the recurrence relation part. This coefficient equal to 0. Now this in that recurrence relation you put r is equal, means I am now considering the case r is equal to 3 by 2. Okay. And at the beginning I told also that always you start with the larger root. Okay. दो रूट है, जो भी केस हो always you start with the larger root. पहला जो सोल्यूशन आएगा वो लार्जर रूट के करस्पॉन्डिंग. सो देयर हैव अ रीजन, वो रीजन मैं नहीं बता रहा हूं, बट मतलब ये लार्जर रूट से शुरू करना बेटर होगा. ठीक है. सो r is equal to 3 by 2 के लिए I am constructing the recurrence relation. So it is the recurrence relation, sorry, it is the recurrence relation for r is equal to 3/2. ये कैसे मिला? ये जो जनरल डिग्री टर्म का कोएफिशिएंट इक्वल्स टू 0 था, वहां पे r इज इक्वल टू 3/2 पुट किए तो मिला ये, ठीक है। as is equal to minus 1 by s into 2s plus 5 as minus 2. Now here s is starting from where? यहाँ पे समेशन का लिमिट 2 से है, तो s is starting from 2. So a2 will be something into a0 and वो something हो रहा है minus 1 by 18. Similarly a3 will be something into a1. Now what is a1? Actually in the previous, by using the previous this coefficient of x to the power r plus 1, actually apart from this what recurrence relation, we have another condition. देखो फर्स्ट जो है कोएफिशिएंट ऑफ x टू द पावर r, ये हो गया इंडिशियल इक्वेशन के करस्पॉन्डिंग, फाइन। एंड और एक देखो यहाँ पे है x टू द पावर r प्लस 1 का कोएफिशिएंट, तो वो भी इक्वल्स टू 0 होगा सेपरेटली, एंड जनरल डिग्री टर्म का कोएफिशिएंट इक्वल्स टू 0 करके और रिकरेंस रिलेशन मिलेगा। तो बेसिकली वी हैव टू रिलेशंस, दिस एंड दिस। तो बाय यूजिंग that relation, coefficient of x to the power r plus 1, the coefficient of x to the power r plus 1 is equal to 0, I am putting r is equal to 3/2. So ultimately I am getting a10. Okay, a10, and ये जो recurrence relation है वो simplify करके तो ये आया, मैंने बोला तो a10 है, and a2 minus 1 by 18 a0, a3 related to, by the recurrence relation, a3 is related to a1 and a1 already 0, so a3 भी 0. Similarly a5 0, a7 0, and a4 क्या होगा? a4 something into a2, तो वो a0 के टर्म पे चला आएगा. So in that way we will get a2, a3, a4 and so on. तो ultimately फर्स्ट सोल्यूशन क्या होगा? x टू द पावर r मींस x टू द पावर 3/2 into a0 रहेगा प्लस a1x, a1 0 है तो वो नहीं रहेगा, प्लस a2x स्क्वायर, तो माइनस 1 by 18 a0 x स्क्वायर, a3 नहीं रहेगा, फिर a4 x टू द पावर 4 रहेगा, तो a4 है दिस, तो a0 by 936 x टू द पावर 4, और लिखना जरूरी नहीं है, 3 नॉन जीरो टर्म्स आ गया है, तो अप टू a4 तक कैलकुलेट करना, दैट इज एनफ. सो वी आर गेटिंग दिस सीरीज, ओके, y1x. नाउ for the second solution means y2, in that case you consider the second root, r is equal to -1. Okay, so r is equal to -1, again you take that coefficient of x to the power r plus 1 is equal to 0, coefficient of x to the power s plus r is equal to 0, then you put r is equal to -1. So again here I am getting a10, and from the recurrence relation I am getting this. Now here s is starting from 2, so a put s is equal to 2, 2, 3, 4, 5 and so on. So a2 it will be a0 by 2, a3 0 हो जाएगा ना क्योंकि a1 0 है, so a3 will be 0, a5 0, a7 0, and a4 is equal to something into a2, तो वो a0 के टर्म पे अल्टीमेटली आ जाएगा in that way, and ultimately the solution y2 it is equals to x to the power r, तो x to the power that -1, a0 रहेगा प्लस a1x नहीं रहेगा, 0 हो जाएगा क्योंकि a1 0, a2x स्क्वायर, तो a2 मींस a0 by 2 x स्क्वायर, a3 0 हो जाएगा, a4 x to the power 4 रहेगा, तो ये a4 तक करने से हो जाएगा, तो इट इज दिस. देखो यहाँ पे सेकेंड सोल्यूशन निकालना आसान है, बिकॉज the roots are not differing by an integer. So you got y1 and y2, then ultimately general solution y is equal to c1 y1 plus c2 y2. Okay, any doubt?
No, sir.
देखो तुमको सोचना पड़ेगा जो प्रीवियसली जो प्रॉब्लम मैंने किया वहां पे और ये प्रॉब्लम में क्या डिफरेंस है. Whenever roots are equal, in that case y1 जो जैसे यहाँ पे दिखाया वैसे ही आया, but y2 के लिए we have used reduction of order method, but here we are using the same technique. मतलब for r is equal to first root जो मेथड है सोल्यूशन निकालने का, for r is equal to another root सेम मेथड है, राइट. मतलब यहाँ पे और कुछ एडिशनली सीखना नहीं पड़ेगा ऐसे प्रॉब्लम सॉल्व करने के लिए. Now that is another type, x square y double dash plus x square minus 3x into y dash plus 3y is equal to 0. So you normalize it, means convert it to its normalized form, and you can see that x is equal to 0 is a regular singular point. Okay, so y is equal to summation a m x to the power m plus r be a power series solution. I am not telling these things again. तो डेरिवेटिव निकालोगे, इक्वेशन में सब्स्टिट्यूट करोगे, देन सिंप्लीफाई करोगे. तो आफ्टर सिंप्लीफाइंग we are getting this plus summation of this is equal to 0. Okay, so lowest degree term is x to, means that x to the power r. So if the coefficient of x to the power r is equal to 0 gives us the NBCL equation. So r into r minus 1 minus 3r plus 3 is equal to 0. It is the initial equation and the roots are 3 comma 1. And the coefficient of x to the power s plus r is equal to 0 will give us recurrence relation. Okay, now you see the nature of roots here. The roots are differing by what? Integer. 3 minus 1, 2. Now can you tell me if the roots appear to be imaginary or complex, then what will be the case? I have not shown this type of case when the roots are complex. Any idea? और मतलब ये जो प्रीवियस 3 केस मैंने बताया वो 3 केस में आ जाएगा क्या?
Sir, is it the third case because the difference will be integer only?
Yes, it is the third case because
Because the roots are conjugative.
conjugate, correct. Means अगर complex root आएगा भी, then roots will be means conjugate to each other, right? My like अगर ऐसे 3 plus I एक root है, तो another root should be 3 minus I. Now you verify their difference. It will be what? 3 plus I minus 3 minus I. तो नहीं, ये तो मैं जो सोच रहा था वो नहीं आ रहा है. आई आई तो रह जाएगा ना. 6 सॉरी 0 0 प्लस 2i ऐसे हो रहा है. तो ऐसे थर्ड केस तो नहीं आ रहा है. Differing by an integer, not differing by an integer. तो इसको नॉट डिफरिंग बाय एन इंटीजर केस में लिख सकते हैं, बिकॉज ये तो इंटीजर नहीं है, इमेजिनरी है, राइट। क्या नॉट डिफरिंग इंटीजर केस में लिख सकते हैं? बोलो। डिफरेंस तो हम ऑलवेज मतलब आयोटा रिलेटेड ही होगा अगर ए प्लस आई बी फॉर्म में है। So it is included in that difference means not differing by an integer. Roots not differing by an integer. Fine. So here it is the case. Roots are differing by an integer because 3 minus 1 it is 2, which is an integer. So for the larger root you have to write the first solution. So I am assuming r is equal to 3 in the first case. Now we have only, apart from this coefficient of x to the power r, we have only the recurrence relation. So that recurrence relation is equal to 0. There you put r is equal to 3. So you will get this type of recurrence relation. As is equal to minus as minus 1 divided by s. Okay. And since that summation starting from 1, so s is running from 1. Now if you put s is equal to 1, then a1 is equal to minus a0 by 1. So a1 is equal to minus a0. Then you put s is equal to 2, a2 is equal to minus a1 by 2. Then you put a1 is equal to minus a0 again. So a2 will be in terms of a0. Similarly a3 भी a0 के टर्म पे आ जाएगा. तो एंड ये जो डिनोमिनेटर है वो सब फैक्टोरियल के फॉर्म में भी आ रहा है. Therefore I can write y1x, it is a means it is x to the power r, so x to the power 3, then a0 plus a1x plus a2x square plus a3x cube and so on. So you substitute these variables means parameters. a1 को सब्स्टिट्यूट करो, a2 को सब्स्टिट्यूट करो, a3 को सब्स्टिट्यूट करो, तो ऐसे मिलेगा, right? Since we are getting a pattern, that is the reason I have written an, but you can ignore it also. No need to write an. Writing 3 or 4 terms is enough. So it will be a0 into x cube into this. And ये जो series है after taking common a0, that is known series, right? What is the series for e to the power x? One plus x square by factorial 1. Sorry, 1 plus x square by factorial 2 plus x cube by factorial 3 plus x to the power 4 by factorial 4 and so on. तो यहाँ पे ऑल्टरनेटिंग है, माइनस एक्स है माइनस एक्स क्यूब, तो वो e टू द पावर माइनस एक्स का सीरीज होगा. e टू द पावर x का सीरीज में x के जगह पे माइनस एक्स पुट करो तो आएगा ये वाला सीरीज. So I can write a0 x cube e to the power minus x. So that is the closed form of the first solution. Okay. Now in that case also मतलब जब roots are differing by an integer, in that case finding second solution it is a bit difficult because क्योंकि y second solution जब निकालने जाओगे वो dependent हो जाएगा. So how to get independent solution? It is the same procedure of double roots. Okay. डबल रूट्स में जैसे प्रोसीड्यूर था वही प्रोसीड्यूर में y2 यहाँ पे निकलेगा. So here the function is, I can consider a naught is equal to 1. So y1 will be x cube e to the power minus x. तो वी नो दैट सेकेंड सोल्यूशन का फॉर्म ऐसे होता है, बट ये फॉर्म लाना कैसे है, इसके लिए रिडक्शन ऑफ मेथड ही करना पड़ेगा, नो अदर वे. सो बाय रिडक्शन ऑफ ऑर्डर y2 is equal to u into y1 that I have written. Instead of u I have written v. So where v is again what is the formula? Integration 1 by y1 square e to the power minus integration px dx. By that formula I am writing this 1 by y1 square to y1 to मिल गया है x cube e to the power minus x, and what is px? So again for px you have to see the OD. What is px? x square minus 3x divided by x square, right?
Yes, yes, sir.
तो वही जो फॉर्मूला मैंने बताया था वो फॉर्मूला में ये वाला px को पुट करो एंड सिंप्लीफाई करो, यू विल गेट दिस. तो यहाँ पे भी वो स्टेप जंप किया हुआ है, दिखाया नहीं है. अगेन आई एम राइटिंग द फॉर्मूला फॉर v 1 by y1 square e to the power minus integration px dx or dx. Okay. Then y2x will be that is y1 into v. Okay. Now is it possible to integrate it? You think इसको integrate कर सकते हैं क्या? You can try. Okay, whatever you can try. मतलब ये integration is not possible. मतलब ऐसे यूजुअल वे में जो फॉर्मूला बेस्ड अगर करेंगे तो दैट इंटीग्रेशन इज नॉट पॉसिबल. बट एज ए सीरीज वी कैन राइट सम टर्म्स फॉर इट. मतलब ये x टू द पावर -3 इंटू e टू द पावर x, इसको अगर सीरीज में e टू द पावर x का सीरीज में मैं यहाँ पे लिख दूंगा तो कुछ टर्म्स मैं इसका लिख सकता हूँ. तो x टू द पावर -3 इंटू व्हाट इज द सीरीज फॉर e टू द पावर x? 1 x square by factorial 2 x cube by factorial 3 and so on, and after multiplying it will be x to the power -3 plus x to the power -2 plus x by factorial 2, no, not x to the power -1 by factorial 2, then 1 by factorial 3, next term will be x by factorial 4, right? Now you can integrate this, is not it? ये सीरीज को इंटीग्रेट कर सकते हैं टर्म वाइज, क्योंकि ये टर्म का इंटीग्रेशन पता है, इसका भी पता है, इसका भी पता है, इसका भी पता है. तो ऐसे करेंगे तो अल्टीमेटली ऐसे कुछ टर्म्स मिलेगा. Are you getting how I have written this last form, this form? x to the power -3 into e to the power x, ये e to the power x को एक्सपांड किया है जैसे x to the power -3 से मल्टीप्लाई किया है, देन इंटीग्रेट किया है. तो जो यहाँ पे मैंने लिखा, देखो x to the power -3 का इंटीग्रेशन यही होगा ना. x to the power -2 का इंटीग्रेशन दिस, x to the power -1 का इंटीग्रेशन दिस, राइट?
Yes, sir.
तो ऐसे चार पांच टर्म लिख दिए. नाउ actually you can leave it here. The second solution you can leave it here, fine. नाउ ये जो लास्ट जो मैंने 2 लाइन लिखा है वो इसीलिए लिखा है कि जो बुक में लिखा है कि सेकंड सॉल्यूशन का फॉर्म जो है वो आएगा ऐसे ऐसे फॉर्म में, वही दिखाने के लिए। फाइन। तो फॉर दैट मैंने क्या किया है तो ये एक्स क्यूब इंटू ई टू द पावर माइनस एक्स, इसका सीरीज जो है इसका सीरीज मैंने बना दिया। तो एक्स क्यूब इंटू ई टू द पावर माइनस एक्स, देखो यहाँ पे एक्चुअली 2 पार्ट में कर रहा हूँ, एक्स क्यूब इंटू ई टू द पावर माइनस एक्स इंटू दिस, ये कर रहा हूँ, एंड एक्स क्यूब ई टू द पावर माइनस एक्स इंटू द रेस्ट कर सकते हैं ना, मतलब कैन आई राइट दिस एक्स क्यूब ई टू द पावर माइनस एक्स इंटू 1/2 ln x प्लस x cube e to the power minus x into the rest series minus 1/2 x square minus 1 by x plus 1 by 6 x, ऐसे लिख सकते हैं क्या?
Yes, sir.
तो अब इसको सिंप्लीफाई किए, e टू द पावर माइनस एक्स का सीरीज लिखे, फिर x क्यूब से माइनस मल्टीप्लाई किए तो ये वाला है। ओके, एंड रेस्ट ऐसे लिख रहा हूं। अल्टीमेटली क्या हो जा रहा है कि ये एक सीरीज एंड ये वाला ln x वाला टर्म आ रहा है, देखो ये 1/2 y1, ये y1 है ना, 1/2 y1 ln x प्लस जो सीरीज था वो, तो 1/2 y1 ln x प्लस दिस, ऐसे फॉर्म में आ रहा है। तो यहाँ पे k का वैल्यू जो है वो क्या आ रहा है, k का वैल्यू 1/2 आ रहा है। So no need to write it again, I am telling, no need to do this, वो जस्ट फॉर्म मतलब फॉर्मूला का जो फॉर्म है वही दिखाने के लिए ये सिंप्लीफिकेशन किया। एंड लास्टली यू कैन राइट द जनरल सॉल्यूशन c1y1 plus c2y2। so 2 cases I have shown, actually 3 cases I have shown in the Jamboard, I have shown equal roots, then today मैंने फर्स्ट जो प्रॉब्लम दिखाया that is the problem for roots not differing by an integer, and ये जो करंट एग्जांपल है roots differing by an integer। तो roots differing by an integer and double roots, ये दोनों केस में सेकेंड सोल्यूशन निकालने के लिए you have to apply reduction of order technique, बट ऑलवेज वो रिडक्शन ऑफ ऑर्डर टेक्निक भी काम नहीं करेगा अगर मान लो कि ये जो फर्स्ट सोल्यूशन है ये ऐसे कॉम्पैक्ट फॉर्म में नहीं आता, ठीक है, तो वो केस में रिडक्शन ऑफ मतलब रिडक्शन ऑफ ऑर्डर काम नहीं करता। आर यू गेटिंग द पॉइंट? अगर ये मतलब ऐसे कॉम्पैक्ट फॉर्म में ना आके ऐसे सीरीज फॉर्म में अननोन आर्बिट्ररी एक सीरीज आ गया, सो इन दैट केस y2 निकालना मुश्किल हो जाएगा बाय रिडक्शन ऑफ ऑर्डर। तो एग्जाम में ऐसे केस में अगर y1 अगर नॉन मतलब क्लोज्ड फॉर्म में नहीं आता है तो तब एक ही सॉल्यूशन पूछता है। So another example, it is the book problem, na? This one already I discussed. See, okay, now you have to practice. There are several problems in your textbook. In most cases, x is equal to 0 is a regular singular point. In most cases, except this problem number 2. Here x is equal to -2 is the regular singular point. Okay, because the factor it is multiplied x plus 2. You can verify x is equal to 0 अगर देखेंगे तो वो रेगुलर सिंगुलर पॉइंट नहीं होगा। तो x is equal to -2 केस में क्या करेंगे, इसको 0 के अबाउट में हम लोग चेंज कर सकते हैं। यू टेक x plus 2 is equal to z, फाइन, and then you change the ODE accordingly. It will be z square y double dash. Y double dash means dy by dz, means y dash means dy by dz, y double dash d2y dz2. So if you take x plus 2 is equal to z, then this equation reduced to z square y double dash plus z into y dash minus y is equal to 0. Now z is equal to 0 is a regular singular point. Okay, then you take the power series solution in the form z to the power r summation am z to the power m form, and lastly you put z is equal to x plus 2. Okay, क्या करना पड़ेगा, समझ में आया कि नहीं?
Yes.
एंड देखो यहाँ पे लाइक प्रॉब्लम नंबर 7, ये प्रॉब्लम नंबर 7 में मतलब ये जस्ट ऑर्डिनरी एक सिंपल सा ओडी है, यहाँ पे सिंगुलर पॉइंट है ही नहीं, देयर नो सिंगुलर पॉइंट. तो अगर सिंगुलर पॉइंट नहीं है तो क्या हम लोग फ्रोबेनियस मेथड अप्लाई कर सकते हैं? आंसर इज यस. तो एक रेगुलर पॉइंट के अबाउट में भी कर सकते हैं, बट अगर मेंशन नहीं है कि फ्रोबेनियस मेथड में करो, मत करना फ्रोबेनियस मेथड, क्योंकि ये जो 7 प्रॉब्लम नंबर 7 है ना, ये बहुत आसानी से हो जाएगा सॉल्व. जो 5.1 में सीखे हो, बाय दैट टेक्निक यू कैन सॉल्व इट. बट अगर पर्टिकुलरली मेंशन कर दिया कि फ्रोबेनियस मेथड में ही करना है, देन कुछ नहीं कर सकते. तो 5.1 में जो जो प्रॉब्लम्स तुम लोग किए हो, वो सब प्रॉब्लम्स को फ्रोबेनियस मेथड से भी सॉल्व किया जा सकता है. ओके,
Yes.
बट अगर बताया नहीं कि फ्रोबेनियस मेथड से करना है, तो फ्रोबेनियस मेथड में मतलब मत करो. मैं बहुत बार बोल चुका हूँ. What else? Only these problems you can practice, और कुछ नहीं करना. 2 to 13 बस 4-5 कर लेना. सभी करने का जरूरत नहीं है, क्योंकि एक बार टेक्निक सीख गए हो तो कोई भी प्रॉब्लम सॉल्व कर सकते हो. मैं मार्क कर देता हूँ, नहीं तो कौन सा प्रॉब्लम करना है. 2 करना है, 4, 5, 7, 8, 11, ठीक है, ये सभी करो, हो जाएगा इसमें. ओके, मार्क कर लेना.
Yes. Sir.
And deep time,
Okay, sir.
then you can solve all the problems.
Okay, sir.
Okay, so I will give all present today.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you all.